So, you have a good lunch? Almost? Are we ready? Let's try again. Are you ready? Okay. Now let's go. So, my name is Enrico Zimuel. I work for Elastic. I'm a software engineer at Elastic. I'm an old open source contributor. I did Xen Framework, Expressive, Observability, and now I'm the maintainer of Elasticsearch PHP, the client to call Elasticsearch. I'm an international speaker, and actually I'm very happy to announce that this talk is my talk number 100. So, thank you. I'm very excited to be here in Barcelona for this event. I'm also a member of the Linux Foundation for the Laminas project. I will talk a little bit later. And I'm the co-founder of the PHP user group of Torino, because I come from Italy, as you may recognize from my accent. Okay, so I would like to talk about microservices. This is a kind of buzzword that everyone is talking about. So let's have a formal introduction to microservices. I just took the definition for Martin Fowler. So microservices architecture style is an approach for developing a single application as a suite of small services, each running on its own process and communicating with lightweight mechanisms, often has HTTP. So that is the formal, definition. That means basically nothing. You have just to split an application into small application. That's the idea. So, for instance, this is a monolithic application, as we had a lot of this example in the PHP world. This can be like a Uber, kind of application when people can, call taxi, cars, have a share and stuff like that. As you can see, there is this big green application in the center that manages everything. So you can think of one PHP application that manages, the entire workflow, that expose API, whatever. The idea is to migrate from this architecture to this one. So basically, to divide, to split the services into simple monolithic application. So starting from a big one, we want to try to divide the application into small services. Should be micro, because the definition is microservices, but can be also small services. It's just a definition. It's depending on you, depending on the use cases, of course. So what are the advantages, actually, of this kind of approach? First of all, the separation of concern. If you are able to split your application into independent services, you are just, have a separation of concern. So you can even build with different technology, with different team, with different people. Modularity, of course, because we are building services using HTTP. It's very modular. You can, plug and play, change whatever you want. Encapsulation. Everything is in one service. So if you think about Docker, container is a good example of encapsulation. Everything is there, is separated from the outside, so it's quite easy to manage sometime. Scalability is also one of the main advantages of microservices. If you need, more power, you have more traffic, you can just add as many services you want, and you can scale in a horizontal way. Of course, you can also have workload partitioning, so you can decide how to, how to measure the traffic. For instance, if you have different, environment with different, machines, different services, different power, you can decide, okay, 80% of my request goes there, 20% goes down, and so on. So it's very, very simple to partition the work. So these are the advantages, but of course, we have also disadvantages. Service latency. If you are using Kubernetes, Docker, you can have this kind of issue. Debugging. Instead of have one monolithic application where you can use Xdebug, for instance, just to simply debug your PHP application, you have 10 services. So how do you are able to debug 10 services that call each other with HTTP? It's kind of a mess. I mean, it's a different, completely different approach. So the new architecture challenges actually are the auto-discovery. Imagine if you, in the example that I show you, instead of have one big application that is kind of a Uber, you have a small application for, call a car, to reserve, for payment, and this kind of stuff. But you can have more services. So the same services can run on a different, host name, for instance. How you can develop an application that is able to decide which one to call it at runtime is a challenge. It's not that simple. So the auto-discovery means exactly that. Telemetry, you need to measure some way the HTTP call, the request time, the response, the flow. So you have to have some numbers around your application just to know how to build stuff. And last but not least, everything needs to be automated. If you want to do microservices, you really need a continuous integration pipeline that is fully automated. Otherwise, if you are trying to do manually, you will fail for sure. So you need a very good, solid environment to build microservices. It's not just splitting the code, it's more problem comes from the architecture, from the environment, for the services, for the communication. That's the real issue of microservices, it's not the code. Okay, so HTTP is basically the common layer that everyone is using on the internet and even on microservices because, it's very convenient. Everyone speaks HTTP, everyone knows about HTTP, so there is no really choice here. Most of the time, we are exposing REST API using JSON because, again, this is a common standard. The error management is very, very important in a microservices. So how do you manage error? If I do an HTTP request and something is wrong on the services, how do I expose the information? I do some kind nicey JSON. I try to invent my standard. I reply 400 for every errors. I mean, these are the problems, that from an architectural point of view you have to figure out. My suggestion, of course, try to use standard. For instance, application problem JSON is a specification that say, okay, look, if everything has an error, this is the format that you have to use. So everyone can just consume this, application problem JSON, and everyone is happy. Authentication authorization, this is another giant topic in microservices. Because you can think, okay, I am in my intranet, so I don't really need authorization, right? So everyone is trusted by the IP or whatever. But you need authorization, because maybe one service is not allowed to call another services. I just give you this example, the payment services. Which one should call the payment services? Only a few, not everyone. So it's important to have this authorization mechanisms inside your microservices architecture. So sometimes people say, okay, but wait a minute. You are saying that we have to move from internal call by PHP code, socket, whatever, into HTTP. We are going to fail. It's too slow. Everyone knows that HTTP is slow, right? Actually, it's not so slow. Because we are talking about internal application. So in internal networks often use 1 gigabit or even more. Just to give an example, do some math. Imagine that you have an HTTP response of JSON. It's about 5 kilobytes. That is a lot for a JSON API, right? You can have 26K response per second using 1 gigabit. Not too bad, from one node to another. So network connection is not usually the bottleneck. It's not an issue. You have to forget about speed. You have to think about scalability. That's the approach of microservices. Microservices is really needed if you have scalability. If you can scale your application just adding more services out of the box. That's the idea. It's not about speed. It's about scalability. Okay, so now let's jump to PHP. I give you some just, abstract introduction. Let's focus on PHP, because we would like to write microservices in PHP, right? Okay, PHP is, as you also noticed maybe yesterday from Rasmus, was born using, for web application, right? So how to manage HTTP message in PHP? We have this not so sexy way to manage it using global variables that everyone knows that is, the evil of any good developers. So in PHP, if you need to have some information about the HTTP message, you have to manage $_server, $_post, $_get, $_files, $_cookie. Come on. We are 2019, we need to manage global variables for HTTP messages? Sounds crazy, and in fact it's crazy. There are a lot of functions in PHP also to manage HTTP, like HTTP response code, header, header remove, header list, header send, set cookie, set for cookie, get host name, hundreds of functions. So it's not very clear and simple to use all these functions. So it's a mess. But luckily, we had a solution. We had PSR-7, that is a standard, a proposal standard of the PHP framework interoperability group, PHP FIG. Everyone knows about this project? Raise your hand if you know. Okay, almost everyone. If you don't know about the project, I strongly suggest to have a look. I will publish the slide. When you see something in blue, is a link, hyperlink. So you can click it and check it out. So basically, it's a group of people, mainly framework maintainers, library maintainers, that decide to have together to share together some ideas, and they propose some interfaces, so in an object-oriented way. And they propose PSR, standard recommendation. One of, my opinion, the most important is the PSR-7, that is basically a common interface for representing HTTP message. So instead of playing with global variables and Nancy function name for getting the HTTP request and producing the HTTP response, you will manage object in an object-oriented way. Sounds more nice, right? So basically, it's just an interfaces. So if you go to the GitHub page for the PSR-7, this is just a list of interfaces that you have to implement in your project. But of course, there are many libraries that already provide you the implementation, so you don't have to. Just to give you an example, we want to get an header from a request. We have an object, $request. We have a function that is getHeader. We specify the name of the header, and we get the header. That's it. Simple, clear. If you want to check if a request has an header, there is hasHeader function. That's it. You need query parameters, get query params. Simple, beautiful, object-oriented. Okay, so we fixed the issue with the PHP. I mean, there is a way to manage HTTP request and response in an object-oriented way in PHP, thanks to PSR-7. Now let's jump to another topic, that is Swoole. Who knows Swoole extension? Please raise your hand. A few people, okay. So basically, Swoole is an extension for PHP, is a asynchronous programming framework for PHP 7, actually. That's the definition. As an extension, you have to install it using, for instance, Packle, or you have to compile by yourself. It's Apache license, so you can use it even for commercial products. If you're more interested, this is the website of the framework. The feature gives you basically an event-driven asynchronous programming for PHP. You can do asynchronous stuff in PHP, as you do in Node.js, the same way. It provides you a lot of protocol for managing TCP, UDP, HTTP, WebSocket, HTTP2. It provides also the layer, SSL. It's high performance and scalable. It's very high performance. I will show you some numbers. And also give you a fast serialization and unserialization. So that basically is better than the actual implementation of PHP. I mean, it's fast. And also provide you a millisecond task scheduler. So this is something very, very nice if you have a very high traffic website. So this is the architecture of Swoole. So basically, when you run a Swoole application in PHP, the Swoole itself creates a master. So basically, it's a PHP instance that stays in memory, that generates a manager. This is a different process. And the manager will generate different worker. So basically means your application runs, for instance, on this laptop, I have 8 cores. So they will generate 8 workers for 1 core according to the machine. So basically, it's a way to try to use as many, resources the machine provides you. This is an example of an HTTP server. So imagine that you want to write an HTTP server in PHP using Swoole. The same idea of Node. So as you can see here, we are just getting a new server, and we are providing 2 functions, start and request. Start is when the server is started. So as you can see, it's just an anonymous function here. We're just printing this started at information. And you have this other events request that is executed when a request comes in. So if someone sends you an HTTP request to that IP address with that port number, this is the function that we executed. And as you can see, we are using objects, $response header, $response end. So we are just putting an header in the HTTP response and writing down the body. That's it. When you have a start here, basically the Swoole will execute this in memory. And you have a real HTTP server running in a few lines of code of PHP. That means you don't need anymore the web server. Again, wait 1 minute to think about this sentence. You are developing PHP application without a web server. That sounds crazy, right? It's more Node.js stuff. It's not PHP, right? Do you agree? Yeah. So it's a completely new approach of developing PHP application using this extension. Just to give you some benchmarks, this simple HTTP server is able to provide on a very old machine, actually, 60K requests per second. 60,000 requests per second. Not so bad. The idea behind the Swoole is the idea of the event loop, the same of Node.js. So there is something running in memory that listens for specific events on the HTTP. So when an HTTP request comes, you serve the HTTP response. Okay. I give you some, information here. I say, okay, this is the way that you should write microservices. We jump to the HTTP management in PHP. I introduce Swoole. But now there is the final piece, I would say, that is the middleware. What is middleware? A middleware is basically a function that gets a request and generates a response. In some way, in the example that I show here of the Swoole, when there is the events request, this is actually a middleware. You have a request and you generate a response, right? So this is something very, theoretical. Imagine that you want to build an application using this approach. Because at the end of the game, we are building web application. A web application is a HTTP message come in, do some stuff, and produce HTTP response, right? So it's a string that manipulates a string and generates another string, if you want to see in a very raw way. But imagine that we want to create this middleware and put together. So I would like to write a function that provides you some work on the HTTP request, that pass the information to another function, that do another stuff, and so on. Imagine, I don't know, authentication. Authentication maybe is the first middleware. You want to authenticate the HTTP request. If you have authentication right, you pass the ball to the next, middleware, and so on. So imagine that you want to build like a microservices, actually. The idea of microservices is actually very similar to the middleware. You need basically something that gives you the possibility to jump to the next execution, right? Because these are just functions that are called one to each other. So if we just had, as a second parameter, a callable, that is something that I can call in a middleware, this is very powerful, because this gives you the ability to say, OK, I do something with the request, and I call the next middleware. It's a way to create a pipeline, actually, of execution. So with this simple solution, just adding a parameter of delegate, we can actually create an entire application using this approach. The idea is the same of the kernel of Linux. You have this onion architecture, where you have this application that is built using different middleware, and you call and you delegate the execution to the other middleware. Just to give you an example, imagine that you want to build a caching system for a middleware application. So typically, a caching system is something that is at the top of execution. When an HTTP request comes, I need to check if I already have the response in the cache, and if I have it, I just return the response. Otherwise, I generate the response. So I delegate the execution to the other middleware. What I described is exactly that. If cache, imagine that $cache is some variable, I don't know, memcache, whatever you want, has request, so there is a function that says, OK, I have this cache in my box or not, I just get the response and I return it. So the execution basically ends on this line. If the cache, the request is not in the cache, I need to actually generate the response. And how I generate the response? Just calling the delegate, whatever is calling after. So I call delegate, passing the request, I store the response, I store it in the cache, and then return response. So this line, $cache set, is important because the next time I will consume the cache instead of doing all the requests. So with this simple approach, very, very basic, very, very simple, you can build very, very powerful architecture. So managing an HTTP request and producing an HTTP response using a middleware architecture is very, very simple, is very, very intuitive. And actually, this code is not very far from the actual code, for instance, that I wrote for Zend Expressive Cache. That is a library that do cache for Expressive. It's very, very similar. So the beauty of this architecture is the simplicity. Simple is beautiful, especially if you have a full-time job on software engineering. So I mentioned PSR-7. We have another standard, that's PSR-15, that basically is a way to manage the pipeline of execution of a middleware. It's just an interface. So basically, using PSR-7 and PSR-15, we can build standard middleware application in PHP that everyone that is using the PHP Fig initiative can consume. And there are many frameworks that use this approach. Just to mention one, Expressive. Expressive is a framework that me and Matthew and other contributors built some years ago, based on this idea of the middleware. So basically, it's a light framework, if you want to call it, or micro framework, that is able to give you all the features of middleware. It's actually a new project. I mean, it's come from XZEM framework. So last year, we announced that Xen framework will migrate into another project driven by the Linux Foundation that is Laminas. So we changed the name for legal implication. So now the project is under the Linux Foundation umbrella, and actually this is the only PHP project managed by the Linux Foundation, so it's quite awesome to have a PHP representative in the Linux Foundation. And Expressive is so now part of Laminas. We are still in the process of changing the namespace, because every project under the Xen framework umbrella was Zend. We started with Zen, so we need to change in Laminas. But as you can imagine, we cannot change easily. We cannot say, OK, starting from tomorrow, everyone, the same project will have Laminas as first namespace. We basically broke all the existing application. So what we are doing now is to providing you automatic tools in order to change in your existing application the namespace. It is quite tricky. I mean, there are a lot of use cases, a lot of very, very interesting application, legacy application even, that we have to manage. Anyway, we are very close. So with this tool, will be just a way to install Composer, this component, and you will have the new namespace in Laminas. Let's say Expressive support, of course, PSR-7 and PSR-15. The main features are the routing, the dependency injection, templating, and error handling. So basically, we provide a way to easily route the HTTP request into your code. Everything is dependency injection. So we try to apply, the best practice that we learn after many years. We provide templating and error handling. This is just an example, a few lines of code. You have this $app object application, and you say, okay, look, I want to manage a GET HTTP request with GET, with the path is /API/ping, and when someone send a GET to this URL, you basically call this simple function, anonymous function, that provides you a JSON response. JSON response is a class that we provide in Expressive in order to have a JSON response. So you pass an associative array, and that's it. Of course, this is just a toy example. In a really production system, you don't use anonymous function. You want to use a class that implements the PSR-15 interface that provide you the response, but the idea is the same. So instead of, as a second parameter, as you can see, you can even specify the name of the class that implements the interface for managing the middleware, and that's it. So this is ping handler, and this is the ping handler class. Of course, there are some, namespace, but the only function that you have to implement is actually this one, handle, that is PSR-15 interface. So as you can see, handle has just one parameter, that is the request, and produce a response, and you just pass the same JSON response. So this example and that one are the same, basically. But, of course, you have a class here, so you can do other stuff. Imagine that you want to call MySQL or database application. You can pass in constructor, the dependency. You will consume the model, the services, and so on. So, I mean, the normal workflow of all the framework. We provide a lot of ways to specify routing, actually. I just show a very simple example, but you can even be more creative. You can have, of course, optional parameter in the URL. For instance, in this example, ID is an optional parameter. So this is kind of a REST API where you pass or not the ID. If you don't pass the ID, you get all the list of the user. If you pass the ID, you manage the specific user. And as you can see, there is, as a second parameter, an array, because here you can pass as many middleware you want, and they are executed in order. So the first one is the authentication, because you want to authenticate this HTTP request. If the authentication is OK, you pass to the second middleware, that is authorization. So you want to be sure that the one that has the authorization can actually call the other middleware. And the last is the action itself. As you can see, you can also specify the HTTP methods that you want to implement. The last parameter is just the name of the route. You can also use direct. If you don't want to use this approach, you can just use get, post, patch, delete, whatever name function. So very, very simple approach. OK. So I introduced Swoole, I introduced Expressive. Let's try to combine together. Let's try to use Swoole as runtime for an Expressive application. It's very simple. We provide this Zend Expressive Swoole, so you just require using Composer in your application, and you don't have to do nothing. Your Expressive application will run automatically on Swoole. How I can do that? You have to start, of course, the application. We provide a script that is then expressive Swoole with the start parameter. So imagine that it's like a normal services in a Linux box. You have MySQL service, start, stop, restart, whatever. The same idea. Because actually this is a services, something that is running in memory. We are not using a web server anymore, right? So this is just a simple script that runs in memory. So we have PHP, we have Expressive, we have Swoole. This is kind of a revolution for PHP developer. Because you run a web application using the command line interface, like Node.js, and you simplify the deployment, because you don't need to manage anymore a web server. For instance, you can have just one container in Docker with PHP, and that's it. That's the only technology that you need in order to run a web application, or an API, or whatever you want to call it. It's quite awesome, right? Some benchmark. I promise you some exciting benchmark, and here are the results. With this approach, a normal PHP application is from 2 to 4 times faster than Nginx and Apache. Okay, you got it. This is just a benchmark that I did some actually years ago. So maybe now I have to redo again just to see. Now actually Swoole is a full-time project for at least 2 employees. So they are doing a lot of nice. Our Chinese developer, the Chinese community in the last year is very, very involved in a PHP project. I don't know why. I don't know if there are some reason for that, but it's a fact. Maybe there are a lot of people, so it's good to have the help of such good developers. Okay, but again, I started my presentation saying that a microservices is more than just code, is more than just an API. If you really want to do microservices, you need to manage the environment. So basically, the architecture, the entire architecture. Basically, you need, for instance, logging. You need to aggregate the logging. So all the logging produced by all the services should be in one place, in one database. You cannot have file split into containers, services, whatever, and you try to grep the information on this giant log file. It's impossible, absolutely impossible. So you have a concrete way to aggregate the logging. You have an instrument for monitoring the application, so you have to get some telemetry, some metrics behind your application. You need to know how many milliseconds this HTTP response is produced by this HTTP request, how many memories allocated by the services, the CPU usage, and so on. And you need also an application performance monitoring for debugging. Because as I said, you cannot use Xdebug for a microservices. I mean, you can use for a single services, but if you have to debug an application that call another application, that call another application, and so on, you cannot do that. And actually, you need more. You need a way even to track this jump from one service to another. And this is actually distributed tracing. So distributed tracing is just a piece of information that lives in the HTTP request, an ID, basically, that is present in all the following requests. So if you have this link, basically, this ID, and if you have a system that is able to collect all this information, you can actually trace your application. You say, okay, this is the services that call this and other services because you have this ID, this reference. So it's very, very important to have distributed tracing in microservices. And there is a proposal for standard, but actually a standard de facto. This is open tracing, for instance. You can check it out if you're curious. So basically, this idea of microservices lives under this name that is observability. So you need a way to observe the running of your entire application, entire microservices. So you need logs, you need metrics, you need trace. And this is where Elasticsearch can help you. Elasticsearch is a database. Actually, it's a high scalable open source full text search and analytics engine. This is the definition. That is very fast. I mean, if you try to use Elasticsearch for, almost near real-time application, a lot of people are using it. Even with, trillion of records, trillion of documents, it's very, very fast. So it's designed to be fast for the search. And this is very important, because if you have a microservice application, if you, for instance, want to debug an application, you don't want to spend time building a query to search in your database and wait seconds for the response. You need something that is, give you the answer just in time. It's designed for scale horizontally. So you can, if you need more power, you can just add another instance of Elasticsearch, pulling in the cluster, and that's it. It's automatically, balanced between the nodes. And last but not least is REST API. So the beauty of this approach is everything, all the features of Elasticsearch, and actually all the features of the Elastic products, are just a REST API. So you can just consume a REST API in order to index a new document, for instance, to search a new document. Everything is REST API. So it's perfectly aligned in this idea of microservices. Example in PHP. This is the library, the official client for Elasticsearch PHP. If you want to ingest some data into Elasticsearch using PHP, very simple. You have this client, you create the object, you pass the information, so the index, the type, the body, whatever, and you have this index function that is a way to create an index into Elasticsearch. That's it. A response is an associative array with all the information of the REST API. So basically, this is a simple wrapper of the HTTP call for Elasticsearch. But I said, okay, now we have a system, we can put everything into this Elasticsearch, but how we can query the information, how we can search for debugging or all this kind of stuff. We have another product that is also open source. This is Kibana. This is basically a UI that is a window into the Elastic Stack. It's a way to query, using also diagram graph, the information. So it's very, very simple, very, very intuitive to use it. You have just to, look for specific ID or specific text, specific keyword token, and Elasticsearch will provide you the answer. It's also nice because we have an additional feature on top of the open source stack, the Elastic, for instance, machine learning. So basically, this is an automatic way to discover anomalies in Elasticsearch data. Imagine you are storing all the HTTP request and response of your application, even the execution time. You can have some peak, right? This is a tool, machine learning, that is able to analyze the normal behavior of your trends, of your traffic, and just show you if something is unexpected. So maybe it's not a big deal, maybe it's an attack, maybe it's a bug, whatever, but this is an automatic tool, very nice feature to have it. So in this diagram, we have an overview of the majority of the products involved in this presentation that are basically Elasticsearch, that is the database that collects the data, Kibana, that is the UI, so you can interact with the Kibana and ask it for information. We have also a Logstash. Logstash is an Elastic product that's open source that is able to get information from syslog, from the log of, I don't know, web server, MySQL, whatever you want to ingest, and put into Elasticsearch. And we have also APM, that is basically the application performance monitoring of Elastic, open source, but where your application basically can send specific information to Elasticsearch. Imagine that you want to debug or even track specific piece of code of your application. For instance, I don't know, the login, maybe, the login page of your application you want to track in a specific, you want to store, I don't know, how many login you have, how many fail in the login, this kind of information. You can actually, using APM, say, okay, look, this code, starting from this piece of code to that one, so you have to basically put some placeholder, start and end, into your code. And basically, the APM agent will just get this piece of code, taking the execution time, all the information you want to store it, and send it to Elasticsearch. This is just a representation of the APM. So basically, APM using Kibana is just a specific view of your code that you are ingesting. And as you can see, we have this transaction sample. This is very, very important for a microservices approach, because here is where the distributed tracing happens. Because as you can see here, we have 2 bars in blue and other in green. Actually, these green are another services that is called by the blue one. And you can see there even the parallel execution. You say, okay, at this time here, I call another services here, that is the green one, but I'm still using the blue one. So this is just a way to show how the application is running, how you can, fix stuff, how many requests, how many execution time you are spending, and so on. If you don't have this kind of information, it's very, very hard to build a microservices application. Okay, APM and PHP, I say that we have this agent. Actually, even here we have a REST API if you are interested, if you want to see how ingest data into APM and also in Elasticsearch. We have this intake API, so it's a public document. Everyone can use it to ingest data into APM server. We have also a community agent provided by one contributor. This is the GitHub name for the project. And the good news is that we are working on an official APM agent for PHP. I mean, Elastic is working on APM agent for PHP. And this will be an extension, so a PHP extension, because of course we want to provide you an automatic way. You install the extension, you don't have to do nothing, you get all the information from execution time, memory allocation, and so on. And also a library. I think it's important to mention that we provide both, because a library is where if you want to have auto-instrumentation, you can have the extension. But if you want to isolate piece of code in your code base, you have to use a library and specify just the start and the end in the points that you want to monitor. That's it. Okay, so I finished my presentation. I don't know if there are questions. Thank you. Thanks so much. Okay. I have to say muchas gracias, right? My Spanish is horrible, even if I'm Italian.
Sorry. So we had before a talk on React PHP, so I guess the question is obvious. How does Swoole compare to React PHP? Differences and things like that?
Okay. So basically, Swoole is more, an extension rather than React. PHP is a library that provides you, using the actual API of PHP, an asynchronous framework. Swoole is more than that. It's not just a asynchronous framework. It provides you a lot of other features. Like I didn't mention, for instance, the coroutine is a way very simple to provide asynchronous approach. Is used in Go, for instance. If you're familiar with Go, you have this coroutine, and you can have the same in PHP. So it's more than an asynchronous framework.
And people are asking if Swoole is ready for production, or if you are aware, I guess, big clients using it already.
Yeah, there are at least two customers, actually ex-customer of Zen that use it. And it's, again, in China, it's very, very, very popular. A lot of big social networks even are using it. So I don't know the name. Don't ask me the name because I'm not able to.
Yeah, we're running a bit out of time, so are you staying for a while? We'll do 2 more questions, but
yeah,
running out of time.
Around. So. If you have any question, feel free to.
A question about microservices. What is your thoughts about like whenever you have a chain of calls or like microservices that depend on each other? Would you be up for all API HTTP requests or like versus the approach of sending events to perhaps some RabbitMQ and process that like kind of asynchronously?
The idea of distributed tracing is almost this one. I mean, if you have a same ID in all the header of the HTTP chain and an instruments like Elastic, for instance, it's quite easy to collect all this information and provides you in a dashboard to see, okay, this was the call and debugging a normal application. So it's important to collect, but also to be able to query the information. Otherwise, it's like data backup and restore. You do the backup, but did you test the restore? Who tests the restore? And when you need it, it doesn't work.
And a final kind of philosophical one, and actually has some likes. So if we are killing, maybe perhaps we are killing domain-driven design, some of their patterns with this new, well, not new, but middleware approach that is emerging now? I don't know. I mean, it's different level. This is more architectural than methodology for, development. Okay. And we know there are like a million of questions more, but we only have time for one more if you want in the audience. No? Okay, well, try to chat with Enrico. He'll be around for a while. And thank you, Enrico. Thank you.